Welcome to our section on data structures. In this section, we're going to take a look at Python's four primary built-in data structures: the list, tuple, dictionary, and set. Welcome to section 2, starting with our discussion of Python's built-in list data structure. In this video, we're going to look at how a list is organized, learn how to access information stored in a list, and take a look at several ways to manipulate lists. When we say that a list is a data structure, we mean that it's a data value which can contain many subvalues and organize them in some specific way. In the case of a list, the subvalues are organized in a specific sequence. There is a first subvalue and a second subvalue, and so on until eventually we reach the last subvalue. Lists can have any number of subvalues, from 0, which we call an empty list, up to however many your computer can hold in memory without overflowing. In this picture on the screen right now, the words first and the letters A, B, C, D, E, and F, and then the word last, are the subvalues stored in a list, while the group of blue boxes represent the list itself. The numbers underneath the boxes represent the index of each box. The index is a number which is used to identify that particular box when we are trying to access the data values stored in a list. Notice that the index of the first value is a 0, not 1. Using a zero-based index scheme makes a lot of the underlying math simpler when working with a sequence, and so most programming languages use a 0 to denote the first item in a sequence. Python is the same. There are a couple of different ways to implement a list data structure. Python's built-in lists are of a type commonly referred to as a vector. That means that looking up subvalues by their index numbers is a very fast operation, as is appending or removing a subvalue at the end of the list. However, inserting a value at the beginning or middle of the list is somewhat slower. There is an alternate way of implementing lists that is fast for adding subvalues no matter where you do it, but that version is slower for looking up subvalues by index. Since looking up by index is a more common operation, the version of a list that does it fastest is the one that Python has built in as a fundamental type. Each kind of data structure is good for some cases and not so good for others. Being able to pick the right data structure in a given situation is a big part of what qualifies someone as a capable programmer. Alright, so how do we actually work with a list in Python? Python has a special expression syntax for creating a list. What I've just done here is create an empty list and store that empty list in a variable called myList. Now I've replaced the list that was stored in the myList variable with a new list, this one containing the letters A, B, and C. Here, I've retrieved the second subvalue from the list. We use the same square brackets that are used to create a list, in a different context, to retrieve the subvalue from the list. This is called a lookup expression. We'll see that syntax used with other data structures too. They all use square brackets to look up a subvalue, even though only lists use square brackets in the expression to create a new one. I've just added a new subvalue at the end of the list. The list should now have 4 subelements. Let's check. The len operation tells us the number of subvalues stored in a list, or any other data structure, including custom data structures if they're properly implemented. Now we've appended the contents of a whole other list to the end of myList. Since it had 4 subvalues before, and we've just added 3 more, myList now has 7 subvalues. Even though I said before that inserting a value into the beginning of a list is slower, that doesn't actually make it slow in most situations. We've just added the word first into the list at index 0, making it the first subvalue of the list. All the other values in the list have been pushed back, so what was at index 0 before is now at index 1, and so on. And so here we have a Python list that contains the same data as our picture did, constructed through several different Python expressions. We've seen how to create and add subvalues to a list, and retrieve them by index, but we haven't seen how to remove subvalues. The pop operation removes a subvalue from the list, and gives it back to us as the operation's resulting value. By default, it picks the last subvalue of the list to remove and return, but it doesn't have to. This time, we've asked it to remove and return the first subvalue, which has an index of 0. Since we removed the first subvalue, the subvalue that used to be at index 1 is now back to being at index 0, and all of the later subvalues have moved one step closer to the front of the list. For any list that isn't empty, we can also use negative numbers to index into it. Negative index numbers count from the back of the list rather than the front. Since there's no such thing as negative 0, and for a few more esoteric reasons, the reverse index of the last subvalue is negative 1, negative 2 is the last value before that, and so on. One last thing to mention here is that Python won't let us access an index that doesn't actually have a subvalue stored there. This is how Python reports an error if the program does not handle it. In other words, we asked it to do something impossible, and instead of trying and causing some sort of disaster, it just refused and gave our program a chance to handle the error by trying something else. Since we didn't, it simply reported the error.